Okay, so I'm gonna give a small introduction why we are here. So first of all, we work at OP Bank. OP Bank is the biggest bank in Finland, and especially we work in the OP Lab. It's the innovation unit. We have lots of different kinds of technology and discovery projects ongoing, and currently Findi is one of these projects. And when we talk about Findi, there are lots of different meanings about what is Findi. We have a Findi consortium in Finland with different companies and public entities working together with the actual network and the rule books. There's also a legal entity, a cooperative company established. It's named. It's based on the Findi consortium, and its name is Findinet at the moment. And this project has been kind of a spin-off from the Findi consortium work. And the agency we are talking about today, it's developed by OP Bank. And the aim is to actually create a enterprise-grade agency to be used with Findi and also other self-sovereign identity networks. And how did we get here? So, little history. I have been working with blockchain technologies and crypto technologies over 5 years now at OP Bank. And in the early days, we got interested on these public blockchains and pretty quickly find out that the blockchain technology used in those networks doesn't actually fit for the highly regulated banking sector. So we started building decentralized networks for different kinds of financial assets with our partners. These are so-called consortium networks. We built a real estate trading network. This is actually in production in Finland with 94% market share. Then we had experimentation with the company shares network and also with different kinds of trade finance networks. But there was a big problem with these kind of networks, and it was the issue with the identities, that the identities within these networks was not interoperable. So there is a need for decentralized identities, and especially for identity data. For example, company identities, know your customer data, and proof of authority claims. Those were a big problem for us. And of course, the self-sovereign identity seemed to be the all-in-one solution. And that led us to actually do some experimentation. And you really can't learn anything deeply without experimenting with the technology. And we started with the mobile edge clients and test networks. But we wanted to make the solution as pragmatic as possible because we have been playing with these technologies, with these blockchain technologies for a long time. And we wanted to make something that is actually useful from the point of bank. And eventually our experimentations led us to build a cloud-based service, and it has quite distinct features compared to other solutions. More on this later. And you can actually read about the technical experimentation journey from our website. There's a blog writing that Harry has been writing, and it's a really good stuff. So our goals are to actually provide enterprise-focused solution for self-sovereign identity. And that means that we are going to use the best practices in the financial sector. And this means that we need to be compliant with the financial sector regulation. We need to have the proper identification, authentication methods, and also handle the data privacy in a proper way. And this is no easy task. And also we have different kinds of regulations with how do we actually deal with the contracts and the identities related to the contracts. But even though we are building this inside our bank and for the financial sector, we want to be compatible with the world. We don't want to build a silo or a single platform. We want to be fully areas interoperable, and we want to follow the common internet standards. For example, verifiable credentials. And also, we want to give something back to the community, and that's why we have released this as an open source. We hope to get contributions at some point, and we hope to have some kind of a cooperation with this technology, so we can push this further. And next, Laura and Harry will tell more about the actual technical solution.
Okay, thanks, Pekka. Can you see my screen now? I'm not used to this Zoom sharing.
Yeah, it's
okay.
Coming through.
Great. So like Pekka said, we are going to show you a demo. So we didn't want to do any boring PowerPoint presentation, but be brave and try to show it in action. Let's see how it turns out. But let's start with the overall architecture of our Findi agency solution. So maybe you get an idea that what have we built from there and what we are about to demo. So here is an architecture overview picture. Here in the yellow background, you see our backend that consists of currently three microservices. Those are implemented with Golang, and our solution is multi-tenant, so it's able to serve multiple clients. The one installation is able to serve multiple clients. For individual users, we have built a web wallet, which is a React application, and it actually uses the agency services through a GraphQL interface. And for the organization agents, or as we call them many times, service agents, we have an API that's built with gRPC. So the organization clients can use the agency services through an API. And both of these clients use the same authentication model. So we use the FIDO protocol. We have a FIDO server running here in the backend, and with this web wallet, in this web wallet case, the browser web authn capabilities handle the web authn interaction with the server, and in the organization agent case, we have built for them a headless authenticator. And what we are going to demo is this web wallet, how it works, and how we can build these service agents. And I will show them from one angle, and then Harry will continue with another angle. Okay, but let's start by creating a user to the web wallet, and I use here our AWS cloud environment where we have installed this agency. But you can easily try the same in localhost as well. So if you go here in our website homepage, there is this try it out link. If you click there, you can find really detailed setup instructions how you can run this agency in Docker containers in your local host. So I recommend you all to try it out. Anyways, let's start. So first we need to register a user. So we will register a user and bind his authenticator to the new account. And I will now pick a unique username that might not be used already and hit this register. So now browser asks me that which authenticator I want to bind to this account. I have two choices. So either the hardware USB security key or this device authenticator, and I will choose this device. And now the device is verifying my identity either by giving my password or using a Touch ID. So I will use the Touch ID, and hopefully our registration succeeds, and it succeeded. So we have here the text that you can now log in. So now I have now registered my authenticator to the service, and I can use it to log into the service. So now when I tap this login button, it will ask me to identify myself again, and I will use my Touch ID to log in, and we have created a new user and logged in. And of course, we have an empty wallet here, no credentials, no connections yet. And for that, for issuing and verifying, I will show you the use of this kind of issuer tool that we have also created. So I'm running this issuer tool in my local host environment. I have connected with this issuer tool to the cloud agency installation. So if we check the architecture diagram, so this issuer tool is like this one kind of service agent that has a single identity and has onboarded itself to the agency and can now issue and verify credentials with this API. And we have built this kind of tool. I think these kind of tools are pretty familiar to you. So there are existing multiple different solutions for this kind of testing. But why we built this was in one hand to use it for testing, and the other hand to test out how it feels like to use this our API from JavaScript application. So this is a Node.js application that we are using, and it's using this API to the agency. Okay, but let's try to make a connection. Okay, and now we have a new connection. So this issuer tool is kind of really simple. It doesn't have any feedback. But we have a new connection here now, and now I can test here to send a message to this user. So it sends a pairwise, basic message to this user, and then I can also test issuing. I can pick which pairwise connection I want to use, and then I have already created a credential definition before to this system, so I can use it. the one I have already created before. This is really simple credential with one attribute that is called email, and it has the value test at example.com. And I can send the credential offer from this UI. I receive it here in the web wallet, and I can tap here that accept. I want to have this credential, and now I should see a new credential in my wallet. Yay! Back to the chat, and I can also verify the credential from the Issuer tool. So same thing. I just pick the pairwise connection and the same credential definition, and of course this verification is kind of different thing because it's a two-part thing. So agency is the one which is making the cryptographic proof for this proof, but then it sends if that goes through, it sends these values to the Issuer tool, and Issuer tool checks that. Okay, that is there an attribute called email that has the value test at example.com. So that is what happens in these proof requests, and user accepts that he wants to prove this information, and that goes through as well. Okay, but I think these use cases are really familiar to you all, so nothing new there. What might not be so familiar is the way that we are calling the API and using the API. So this part here. So we have we are using this gRPC API, which means that it's like, if you're not familiar with it previously, it's like REST but better. So it's working on top of HTTP2. And the API is defined using this protocol buffer language, and you can generate wrappers to different languages from this API definition. So for example, we have been using mainly Go and JavaScript, but you can create similar wrappers for Python, Java, C++. I think there are really a lot of different alternatives. So our API is polyglot, but still we don't have to like do this REST stuff, parse the JSON and so forth. So we can use the own structures of the language. If we check an example here, we have this FinDecommon TS library that helps these Node.js applications to use this gRPC stuff. So, well, this part is just like opening the connection and setting the proper settings and so forth. But then the interesting part starts here. So if you check that. For example, here when we create the invitation, we just call function called create invitation. So we don't have to like fill a JSON object and post it to some endpoint, but the wrapper, the gRPC wrapper, is handling that all dirty stuff on behalf of us. And another cool thing here is that now that we have the agency running in the cloud, we can start listening to the agent events here. For example, here in my localhost machine. So in this with this kind of start listening call, we open a stream from the agency, and the agency can notify us using that stream. Whichever events our agent receives. So, for example, here, whenever we get a new pairwise connection established, we send a new basic message to that connection and say to that other end that hello world. And this all all happens without exposing an endpoint to the internet. So we don't have to have like any sort of ngrok running in our computer or like any webhooks attached to the agency. We just open the gRPC connection and then we have the pipeline open. So this has been a really useful development approach for us, because we have had like this one agency installation running in the cloud, and then we can all develop our own service agents locally easily and use the web wallet or whatever wallet that is compatible to test our local host application. Okay, but I think that was my demo. Harri, go ahead.
Yeah, sure, thanks. All right, I also try to use the Zoom probably. So maybe I'll share the whole desktop. It's the best idea. Do you see my screen?
Yes.
Yep, that's good.
Okay, good. All right. I try to continue from where Laura left, and about the architecture, there was that diagram where is the backend, and there is a couple of, as we call it, service agents and those clients, and it was something we figured out during this quite long period project, that we don't have to use the did pairwise at the edge agent. That's our approach currently. When we found out that we could use the FIDO authenticators, it was interesting that the protocol which is behind the FIDO2, it's exactly equal to connection protocol in DID world, but it's not symmetric, because the authenticator is a passive device, so it doesn't need to share its public key to the or other round actually. But as Pekka mentioned also, that because our background is financial sector, we are highly regulated, and it affects certain things, and we would like to be able to bring this technology to our offering as fast as possible, and then we have to also take care certain things that we cannot make everything from the scratch, that because there is too much work for those guys who are dealing with the regulator. So that's also been our approach when we have tried to find the optimal architecture. I have gathered some things here, what we have learned during the whole project, that what have been guided us, because I think that my background and Laura's as well is more in the, should I say, software or theoretical computer science background. No, not so much crypto, but as well that too. And because of that, we have tried to be very pragmatic and take care things that will affect the final product quite much, like the performance and scalability. But let's see the demonstration. There's lots of panes here, lots of small windows, but I thought that I start from the situation where where I am actually in Ubuntu, and I don't use Docker because I don't have to. And in certain point of the development process, it's more easier that you just start those backend services as them are, and you can like more easily hook the debugger or something like that. But what I have here, the upper areas, the left one, that's the our FIDO2 authenticator server, and the right one is the our agency, as we call it, the multi-tenant agency. And then I already have a couple of onboarded agents in my system. This is the demo Alice, and that cryptic UID is the pairwise connection ID we are using. And how I have implemented all of this is that there is a bunch of pretty tiny Bash scripts which are running above our command line tool, and this command line tool is like a very similar to, could I say, modern command line tools like Code Control or Docker or Git or something like that. That there are you can do everything with this. But the communication between the agency and this one, it goes through the JWT token and our own headless authenticator. But let's see what you can do with this. For example, let's measure also that how fast this is. Because, as I said, I have already a pairwise connection between demo Alice and demo Bob. Demo Bob is below there, and that is actually correct figure. It's like a 50 milliseconds, and it runs really, but of course in this same machine. And there is Bob, and I could now, for example, start the listening process that I could see that what has been happening during that I wasn't connected, as Laura explained you that you easily can stay like online, because the gRPC protocol, it's streaming protocol. It works both direction, but you still don't have to be a server. You can be a client. Let's see what's here, like the agent, and I can say that listen it, and now it says that this is what is happening, and if I enter other one, they are coming here as well. So it as you can see, everything rounds through the agency. About the agency in this point, you don't have to have only one. Everybody can have own agency if they want, because it's so tiny, and it's only have about 20,000 lines of Go code, because when we started to build it, we started to build it as multi-tenant server. So everything is multi-tenant in both directions through the ARIES protocols, and as well those FIDO authenticators as well. Let's see some other demo, maybe. I can start here the listening process, as we call it, and the other one could be like no, that one, but that's almost similar what Laura showed you, but I'll show this because we think that it proves how smoothly you can play with this when you are doing the development. So let's send something to Bob. And it works, as you can see. We could even send some files through that pipe if we want. Let's see if I would have some quite big there, but is it here? Yes. And it went through, and they really are the basic message from the ARIES protocol. I thought that because we are limited with the time, that I start with when the pairwise is already done, and now I could show something that I mentioned, that we have like a DevOps commands as well. I could ask from the agency itself that what is going on. There is this count command, and it says that there is 6 open wallets, and there is registered, and that's real figure, 11,240 wallets, and we have own pooling system which is doing that. It seems to, when we have tested and stress tested it as well, it's working pretty well. Maybe I saw how you could do the pairwise with these scripts. So like first I would wait a second, because I have to do it like this. Some name, for example, demo X. Now I have onboarded agent. It really is onboarded in the core agency as well. You saw that mostly it happened in the authenticator server here, this window with this FIDO2 authenticator server. But let's make a second one. Now I have allocated 2 agents from the agency, and I would like to have make a pairwise between them. I would do it like this, if I remember right. We have tried to build everything like Linux or Unix pipe and filter architecture. So let's try. Connect would be the command here. Yes, now I have the pairwise command, and I could show same thing to you as I did earlier in the right side windows. But because we are limited with the time, I thought that maybe I will end this with showing that there is situation where I have already been connected to our cloud agency. It's running on WS, and I have had this connection for some hours now, and the command line is called OP Alice, and Carol2 is this web wallet, and I could send hello again to the Carol2, and there it was. And let's watch this reader here because this is a script interface. Everything is splitted like small pieces. So let's answer. Was it Alice? Yes. And it works, as you can see. It came through there. Of course, we could show how the most important things do, but Laura showed them as already. You can actually play it with the verified credential pretty easily from the command line as well. So I hope this showed that this works pretty fast. I'm still hoping that it could be more faster because if we think that there will be much of DIT resolving and stuff like that, we could achieve almost same performance figures like a DNS server. But I don't know what you guys think. But that was my demo.
Okay, thanks, Harri. Maybe it's time for questions if you have any.
That was awesome. Wow. Lots of thoughts. Just wanted to confirm under the covers, it looks like you're running Indy SDK under the covers and I assume the Indy wallet within the Indy SDK for storage and persistence.
Yeah, that's true. It's actually the most stable component of ours that when I started, it's almost 3 years ago, yeah. I built a Go wrapper over the Indy SDK. Yeah. Okay. And we haven't had any problems with that.
Yeah. Have you run like any performance demos or tests with just hammering issuers to many wallets?
Yeah, if you mean that those wallets are ours, yes, we have, and it performs extremely well. Those figures that they goes, we have these because Go offers those not only unit tests but benchmarks as well. Yeah. Both issuing and proofing, if I remember right, a little bit slower. It goes round to round, end to end in 130 milliseconds. But there's no any network lag in that figure because Go simulates the network layers in those benchmarks. Yeah, but otherwise it's a real thing. There is persistent for our state machine storage and also persistent those wallets as well.
Lots to think about on this.
So I saw on one of the previous diagrams that the connection type or the transport you were using between various components was a gRPC connection. Are you passing DIDCOM messages over that gRPC connection, or are you using gRPC in the traditional way?
Not passing DID messaging, but using it like the ordinary way. Yeah.
Yeah. For those who aren't aware, the Findy team submitted a Aries test harness back channel a few months ago, and all tests basically work and run, like all the DIDCOM tests, all the interoperability tests in the test harness run with Findy and Akamai, for example. So, just the back channel appeared one day and all the tests ran, everything worked. So definitely doing full Aries interoperability with all of the other frameworks. Really good.
Yeah. So that has been one of our topics this fall, that we have been enhancing the interoperability. So we did our first interoperability tests. Was it like 2 years ago with Akapai? And everything worked back then with Akapai, but then we started to use the harness, and it revealed lots of good issues that we have been then fixing, and now I think we're in a good state with the interoperability. Of course, like more needs to be done, like always, but anyways.
Yeah, that's true. There's because I have this audience, maybe I put it out that the last thing there is the routing thing, that because it seems that currently the Aries DID protocol, it's like a statically routed, that endpoints have to know that what is the road the message should take, and I don't know how good idea it actually is, but it was a surprise for us, and we have to take care of that. I think that it's one of the last things that there is. Everything else, like the invitation formats and some other little issues, they went pretty smoothly.
Awesome. I am so grateful